Thank you very much for coming. My name is Sérgio Moura. I'm an Android developer here at Onfido. I know some familiar faces around here, but for those of you who don't know, we develop mobile SDKs for identity verification, which basically is we help businesses onboarding their users. And I've been here for 2 years, so for the last 2 years, I've been working mostly on the development of Android libraries. And today I want to share with you some tips and tricks for library development and focusing more on the differences between app development and library development and focusing on some problems that usually you don't have when you develop an app, but things that you have to worry about when you develop a library. Okay, so first of all, who here develops Android libraries? Okay. It's a small number, but still. It's going to be even smaller now. Who here develops Android libraries that are used by external applications? So applications that you don't have control over the source code. Okay, I see like 4, 5, 6 people. Okay, these are the most difficult ones. Okay, so here is the structure of a regular Android library. You can see that it's pretty much similar to the structure of an app. And I decided to organize my tips and tricks by splitting them into the file or folder that they apply to. So first of all, assuming that you use Gradle as a build system, we're going to start by the library's build.gradle file. And the first trick is a very simple one, but can bring you big trouble if you don't apply it. It's called resource name prefix. So imagine that your library has UI components and it has a resources folder, and inside you have your drawable folder with a vector drawable called logo.xml, and you also have a layout folder with a layout inside called activity_camera.xml, which basically lays out an activity that should show your camera preview. And imagine now that there is an app integrating your library that has exactly the same files as you, and it's not as uncommon as you think, believe me. So what happens during build time is that Gradle will merge the app plus every dependency of the app's resources, and a few rules will apply on these conflicts. So if the app defines a resource with the same type and name, for example, drawable and logo, or layout and activity camera, if the app defines this resource and a library that the app is integrating defines the same resource, the app one will take priority and will override the library one. Also, if the app doesn't have these resources but integrates 2 different libraries that actually define the resources with the same name, the one that will take priority is the library that is defined first in your dependencies block, in your build.gradle file of the app. So it's pretty risky. Okay, so this is the content of our both our logo.xml files. And now imagine that if your library defines an image view with the ID logo, and it should show the logo that you are expecting, the logo of your company, wherever it is. So your expectation is that the image view shows the right image, but the reality is that you will end up with the burger instead, because the app's resource will override yours and you will see the burger. But this is not the worst that can happen. Let's look at the other resource, so the activity_camera.xml. So the root is pretty simple, so they both have a coordinator layout, but the library layout contains a camera view, which should display the preview from the camera on screen, and the app one has an image view with that same logo, and possibly some other stuff, doesn't matter. So what really matters is that once you try to call a method, for example, start, in your camera view that you expect to be there, since the app layout did override the one from your SDK, you expect eventually the camera to start, but the reality is your app will crash with a no such field error because it cannot find the camera view ID, because what it actually has is some image view called logo, and you'll get a crash. Okay, so as a solution, you should define a prefix to be applied to every resource you define, be it a string, a style, a layout. It works for pretty much every XML resource. And to do this, you use the keyword resource prefix inside your Android block, the Android block of your library build.gradle file. And here I have an example of the allowed names that you can have with that prefix. So if you define the prefix as, for example, Onfido, lowercase, then you can put Onfido and the name of the resource, camel case, snake case, pretty much anything as long as it starts with the resource, case insensitive. And yeah, when you do this, you will automatically enable Ide Warnings on Android Studio. So if you define a resource called myString, you'll get a warning saying, hey, this resource is not respecting the resource prefix you defined. However, your library will still build fine. And it can be pretty risky because you can forget, you can ignore the warning, many possible causes for trouble. So you should define a lint rule which will fail your lint checks in case you add a non-prefixed resource. And basically, you need to add a lint options block which states the location of your lint rules file, and you also state that whenever there is an error, your lint checks should automatically fail. Regarding the lint rules .xml file, it doesn't need to be prefixed because it won't ship with your final app, so it will never conflict. It won't ship with your library, so it will never conflict with any app that integrates your library. And you should define for this specific case of resource names, you should define the issue with ID resource name, and you should mark its severity as an error so that it fails, your build aborts whenever there is an error here. But you may say like, oh, but now my build will start failing due to other lint warnings that I don't want to tackle right now. So you can just define them, mark them as warnings, and they will be just that, just warnings. Then all you have to do is go in your library and run the lint task. And I advise you not to run it on every build that you do locally while developing, because it takes quite a long time to run. And instead, what we do here is we run it as part of our CI pipeline to make sure that we will never merge a PR containing a non-prefixed resource. So you're pretty safer in this case. Okay, the next topic I want to talk about is the size impact of your library. And it's a very sensitive one because as a library developer, you don't want to bloat your app with libraries that will make it huge. Okay, so how to measure the size impact of your library? First of all, you need an app because the practical size impact of your library can only be found after you integrate it with an app. Because first of all, as a library developer, you can embed ProGuard rules to be applied when any app that is integrating your library builds. And that the code shrinking and obfuscation that ProGuard performs will happen at the app time with those rules. So you really need an app to determine that. Then the app that you use should be the smallest possible wrapper around your library. And by smallest possible wrapper, I mean an app that, if possible, contains nothing else as dependencies, nothing else than your library. And you still have a small error margin because a simple hello world in Java or Kotlin still weighs around 0.5 megabyte. So you should take that out of the size of your APK to actually find out the size impact of your app. But even this one, you should always keep in mind that the measured size is always the maximum size impact that your library can take. Because if you share any dependency with the app that is integrating your library, the practical size impact of it will come down, because Gradle is smart enough when there are shared dependencies to keep just only one copy of the dependency. So yeah, two important metrics for the size of your library. First one is the APK size of this small app, which can be found by just assembling a release version of the app and then checking the size of the output APKs. Second one is the method count, and it's really important because you don't want to be the main cause for your integrators to go multi-text. So there is a really nice plugin, the DexCount Gradle plugin, that you can integrate, and it can run on every build of your small app, telling you the method count. Okay, now how to reduce the size impact of your library. First of all, first technique is advise integrators to perform ABI splitting in case your library uses C++ code through JNI or any of your dependencies use it. Can be done by defining the split block in your build.gradle file and with all the ABIs that you want to consider. So if your integrator doesn't do this, they may end up with as many repeated native code as ABIs that they want to support in their app, and nobody wants that. The second one is definitely modularization. It's a pretty hot topic in app development, but it can and should be done in library development as well. Basically, the idea is doing the same that the support library does. Instead of shipping one huge library, shipping small libraries that can be used by themselves. And I'm not going to dive too much into it because it's a pretty big topic, but you have here our blog post, which shows our journey through modularization and how we could reduce the size of our library by 48%. So I really encourage you to read it. Okay, next topic, and still inside the library's build.gradle file, is dependencies and how to manage some edge cases around dependency. I will now present a set of 3 really interesting problems that you can have with the dependencies, with your dependencies and the dependencies of any app that is integrating your library. So, first one, imagine that your library is using the version 4.0.0 of some library as well. And imagine that you integrate with an app that is using the version 3.0.0 of that same dependency. As we saw on the slides before, Gradle is smart enough for the shared dependencies to choose just one version. And in this case, it's the higher version. So basically, both your library and the app that is integrating with your library, if they don't force the version to be some version, they will end up executing the 4.0.0 version. And it has a good point because it reduces size impact. Since you are only shipping one version of that dependency, you don't have duplicated code. But there is also a bad side. So it can lead to unexpected behavior. If, for example, in between versions, the implementation of some methods change. Or it can also lead to runtime crashes, because if some methods were deleted in between major version changes, like the 3 to the 4.0.0, yeah, it can lead to big trouble. Okay, so the next one is a very particular example with Dagger, but I believe it could also happen with some other libraries. So, believe it or not, some apps still use Dagger 1 for a few reasons. First, the learning curve of Dagger 2 is quite high. And sometimes the migration process is quite painful. So as long as it's working, they stay on the previous version if they have like an old and huge code base. So imagine this scenario that your library is using Dagger 2 and the app that integrates your library is actually using Dagger 1. And here, Gradle won't be able to override any dependency because they don't share the same ID. Dagger 2 has com Google Dagger, while Dagger 1 has com Square Up. So you'll basically keep both versions of Dagger inside the build. But actually, when it comes to package naming, looking at the module annotation class, the package is Dagger for both of them. And if you try to build an app with this set of dependencies, this is what you will experience at build time. That the module file is defined by multiple text files. So yeah, it's, as of now, is quite hard. It's nearly impossible to have Dagger 2 and Dagger 1 living together inside the same APK. Okay, last problem of this set of problems I want to present is with dependencies that are intended to work as singletons, which means that only one instance of any class should exist simultaneously. And let's take a few seconds to read this code. So on the top block, you have an application, and in the onCreate method of the application, basically, they are initializing some analytics library using the context, using some token, the app token for the analytics library. And on the second line, they are using the library you develop, this samplelib, using the samplelib.init with the context as well. And on the bottom block, we have the body of the init method, which takes the context. And surprisingly, because you use analytics as well in your library, you initialize, and you use exactly the same provider, you are initializing the same library, but with a different token, a token for your library. So now, during the library execution, there is the need to track an event. So you call your analytics library instance, and you call the track method with some event name. So what's going to happen here? Actually, there are many possible outcomes, and you are totally dependent on the analytics library and the way it is implemented for what's going to happen. First one, the analytics library can crash straight away because you are initializing it multiple times. I know some analytics client out there do that. If you try to initialize and it was initialized before, it will crash straight away. But that's not the worst, again, that can happen. The analytics library can also ignore the second initialization, and since it was initialized before using the app token, we can start sending analytics to the host app account because we get the current instance. Since the second initialization was not taken into account, we get the instance that we have, and the instance that we have was initialized here, and we start sending analytics to the host app account. Pretty bad. You are basically adding crap to your integrator's analytics. Or it can be the other way around, and the analytics library can actually accept the second initialization, but since it's a singleton, it overrides the first one, and now it's the other way around. When the integrator app calls the method track, it is actually sending events to your account as a library developer, and you'll get basically data from the clients of every app that integrates your library. Yeah, can be a real pain. So now I want to present you a solution that solves this set of three problems, and it's called Dependency Repackaging, which means that you are changing the packages of Java or Kotlin files in a module for them to not conflict with the host app ones. Here is a simple example of what this means in practice. So basically, we are changing the package of our analytics lib from com.samplelib to com.onfido.samplelib. And if we do this, what actually means is that when you initialize your lib, if you repackage to com.onfido.samplelib, the instance that you are initializing, you are not generating the same instance as the host app anymore. So conflict is over, which is great. But do we need to do this manually for every class of our library? Or do we need to do this every time we bump the version of the library? No. So there are these two very useful plugins, jar and shadow jar, and basically they work at build time. They repackage your library. They repackage the dependencies you need to repackage automatically, and they use a set of rules that you can define. Here is the initialization of the plugin, but this is pretty much straightforward, just like any other Gradle plugin initialization. And the interesting part comes now. So instead of integrating your dependency using implementation, you will instead call jar. And the jar plugin will download the dependency for you. It will repackage it, and it will place it in the build/libs folder with the name, dependency name dash version of the dependency.jar. It works for both Java and Android libraries, but it will only act on the jar of Android libraries. Then you call implementation with the actual file that was generated by jar, and you can start calling the methods of your newly repackaged library straight away. As for the rules that you need to define for jar to work, basically jar offers a pretty straightforward API. So you define which library you want to repackage, and here it's also name of the library dash version of the library, and then you define which packages you want to repackage and what the output should be. And here we are basically saying that we want to repackage everything that starts with com.samplelib, and we want to transform it into com.onfido.samplelib. We are basically prepending Onfido to the package of our dependency. So the good part is that if you look closely, it's still easy to update because we are only relying on one single variable here, which is the version of the library. So if you are using the version 3.0.0 of a repackaged library and you want to bump to the 4.0.0, all you have to do is actually changing the variable with the version, and jar will do it all for you. We'll download the new dependency, repackage it, place it in the build folder with the new name, and then use it with the implementation keyword. We'll import the new version. So it's pretty straightforward. But you should be careful about the licensing of the software you repackage. So depending on the license that this software has, you could be forced to keep a document with all the changes you make to the software, and you could be forced to ship this document with your library. And in this case, the changes we make here is we are repackaging the whole library, or at least the packages under that identifier, to a new package. So this should be taken into account. Okay, next I'm going to talk about the Android manifest of Android libraries, and there are some interesting use cases around it. So the first one, the manifest is not much different from a regular app manifest. You have your permissions defined, and if your library has UI and has activities, you will have your activities defined there. You also have the application tag, even if you are not, you can have the application tag even if you are not developing an application. But let's take a look at this specific property of the activity, which is the label. So the label is often like a forgotten, ignored property because it's useful to state the name of the activity when it is not visible. For example, when you open the recent apps view. And even if it's not defined, it can be, you can get its value from the application label 1. But, however, analytics clients, like libraries that track analytics, they often use it for automatic screen tracking. If you use analytics, you know that most of the libraries, they allow you to, with a simple method call in the initialization, automatically track every screen view that your users pass in your app. And often these analytics clients rely on this property to take the name of the current screen. And if you don't define it, another crash can happen. And this one is from personal experience. So you may start receiving complaints from your integrators saying that your application is crashing. Their application is crashing due to your activities. Okay, next one. This is a piece of code that you can often find in Android libraries right now. So it's a content provider registered in the library manifest. And right now, this is becoming a pretty popular way of initializing Android libraries. But why? So the reason is, so previously, when going through the documentation of some Android libraries, you could see instructions that were telling you, okay, in the onCreate method of your application, which means as early as possible, you should call the init method in our library. And however, content providers came to simplify, not they came because they existed already for a long time, but they started being used to simplify this. Because the good is that there is no need for an application class if you don't use one, or even if you use one, you don't need to basically add many method calls for all the libraries that you need to initialize. And also, it's initialized before any other component, which is often what libraries want you to do. You need to initialize it as early as possible. But the bad side is that it also bloats the app start. So it will increase the app start time since it always runs on the main thread. And it's always run, even when not needed. So in my opinion, unless you develop a library that should always be executed in the app, for example, a crash reporting tool, you should let the developer decide if and when they want to initialize your app and not force them to be initialized right in the beginning of the app. In our example, Onfido, we do an onboarding Android library, an Android library for apps to onboard their users. So you should only need it when the user gets onboarded, and it shouldn't be initialized every time you start your app. Okay, finally, I'm going to talk about an edge case related with the library resources folder. This file, google-services.json. I'm sure that you've all heard about this file. Concretely, if you use any Google or Firebase dependencies like authentication, messaging, well, pretty much everything Firebase related. So this is the recommended way for you to authenticate your apps with Google or Firebase. So you can go to your dashboard, you can download the file, you can place it inside your app, and everything will go fine. You will be authenticated. And this is what typical Google Services.json looks like. So it contains some really interesting information like the app ID, the API key that will be crucial for you to authenticate inside your app. But actually, during the build process of your library, what really happens is that all this JSON file will get parsed by the Google Services Gradle plugin, and it will be translated into resources, in this case into strings, and this information will be used to initialize your libraries automatically. And as we have seen before, if you define these strings, and they are not prefixed with your library resource prefixed. So if you authenticate through the Google Services.json, these strings get defined if an app that integrates your library uses the same not the same, but relies on Google Services.json file as well to authenticate, then it will override your resources, and again, you'll mix accounts, and it will be a mess. But for this one, there is actually pretty simpler solution. It doesn't require dependency repackaging, which is you can simply use the builder that most of the every Firebase library offers, and you can initialize it there, even though it's not the recommended way. It will avoid any trouble in the future with any app that integrates your library. And that's it.